In this episode of Mrs. M's Math to the Masses in a minute or two, it takes way longer than a minute or two. So I've tried to pre-complete this chart. You can stop the video now, go through all those numbers in the first two columns I've created, and make sure you agree with them. I'm going to walk you through what dimension changes do for linear, area, and volume relationships. So in this rectangle, we found the original perimeter to be 28 inches, the original area to be 45 inches squared, and the dimensions are to be tripled. So what this means is for linear relationships, we're comparing the original to something that's 3 times bigger. You have a 1 to 3 relationship. But when we go to work with area of the new shape, we're going to have to consider 1 squared versus 3 squared. 1 squared is 9, 1 squared is 1, 3 squared is 9. It's a 1 to 9 relationship. So when we go to apply these, the easiest way to figure out how it impacts it is to say our original perimeter is 28. We're going to be 3 times bigger. We multiply them together. And 84 inches will be the new perimeter of the enlarged rectangle. That means the new perimeter is 3 times larger than the old perimeter. And over here in the last column, we had an area of 45 inches squared. It's 9 times bigger, because 3 squared would give me an area relationship, and that's 9. 9 times bigger than the old area. 9 times 45 is 405 inches squared. Now let's look at the circle that had a circumference of 88 inches, or 28 pi inches. And if the radius is halved, that means when we compare A to B for our scale factor, we're going to look at what was original, and the image after will be half as big. So if we want to do an area comparison, we'll square both those numbers and get 1 to 1/4. So since the original circumference here in the first column with pink writing was 28 pi inches, we're going to multiply that times 1/2, and we will get 14 pi, which is approximately 44 inches. In small, I'll write that the calculator said 43.98. That means the new circumference is half of the old circumference. It is obviously smaller. And for area, the original area of 196 pi, which we found right here, we're going to multiply that times 1/4, because we're scaling with area, which is a squared value of the linear relationship. So 1/2 squared, I'll just go ahead and make this 1/4. I think that's easier. Times 1/4, and we will get 49 pi, which is about 153.9 inches squared. The new area is 1/4 of the old area. It is definitely smaller. Next we'll work with the Pentagonal Prism. Some might call it Pentagonal Prism. Here we have the perimeter of the base and the area of the base, the surface area of the prism, and the volume of the prism. And the dimension change is supposed to be that everything's multiplied by 1/4. We only do uniform change on this sheet. So A to B is a 1 to 1/4 relationship. A squared to B squared, 1 squared is 1, but 1/4 squared is 1/16. And since we are working with volume, we'll go ahead and get the volume scale factor. 1 cubed is 1, but 1/4 cubed would be 1/64. So let's take that original surface area that we found to be 1800, that was units squared, and multiply it times 1/16, the area scale factor, and we will get 225/2, which is your best answer because it's not rounded. But if we have to run to the store and buy something, we're going to say we need 112.5 units squared. The new surface area is 1/16 of the original, which means the new surface area is smaller. With respect to volume, we had 4,320 cubic units, and the scale factor we'll use now is the cubed scale factor, so we'll multiply by 1 over 64, because 4 cubed is 64, so 1 over 4 cubed is 1 over 64. That will give us an answer of 135 over 2. And that new value will be 67.5 units cubed. The new volume is 1/64 of the original. It is smaller. The last example on the front page, and that may be all you need. You may not need the second page, but the dimensions are being tripled. So our linear relationship will be 1 to 3. Our area relationship will be 1 to 9, and our cubic or volume relationship 1 to 27, because 3 cubed is 27, 1 cubed is 1. The surface area we found 90 pi units. So I'm going to start with the 90 pi for the original surface area and multiply it times the 9 for the scaling factor for area. And I'm going to get 810 pi units squared, which is about 7,290 units squared. That means the new surface area is 9 times bigger than the original. Take the original volume down here at 100 pi. Since we're dealing with volume, we'll choose a scale factor that goes with volume, and we'll multiply to make it 27 times bigger, which gives us 2,700 pi, which when we multiply times pi, be approximately 8,482.3 units cubed. We're obviously getting bigger, and it's 27 times bigger than the original. When I did this earlier and it took so long, I already keyed the only color sheet I had, so I'm going to pull in the second sheet and just try and walk you through it by uncovering things one at a time. Okay. So here comes the second sheet. The first question says, the perimeter of a rectangle is 600 meters. After dilation, the perimeter is 120 meters. So what we want to do is find the scale factor of the dilation. Remember from earlier units, scale factor is always a comparison of the image you end up with over the pre-image value. They just have to be corresponding you started with. So for this problem, we take the 120 that we ended up with after the dilation and compare it to the 600 we started with. It's always an absolute value, it's always positive, but when you reduce that, you get 1 to 5. Therefore, the scale factor for example 1 is 1/5. For question 2, the scale factor of two similar polygons is 3 to 4. The perimeter, so we're using our A to B scale factor because we're talking about perimeter, linear measurement. The perimeter of the larger polygon is 230 kilometers. What is the perimeter of the smaller? So we're going to use cross multiplication to set up and solve for a problem like this. We're going to come in and say 3 is to 4 as x is to 230, and we're putting 230 in the denominator because it's from the larger polygon, and our larger polygon value is reflected as the 4 here. When we cross multiply, we have 3 times 230 equals 4x. We divide both sides by 4, so all you have to put in the calculator is what's in the box. And again, you can stop the video at any time, plug in your numbers. When you get your final answer, you should get 172.5 kilometers. there's pictures of what those pre-image and image polygons could have looked like. Okay, so for our next example, the ratio of two similar polygons is 3 to 4, but notice we've circled the word area. We can't use 3 to 4. We have to use area scale factor. So we're going to square the 3 and square the 4 to set up this cross multiplication problem. Since the smaller one's 140 and the larger one is unknown, we'll have 140 over x compares to 9 over 16. Here's how we're getting our scale factor for the problem. Since it's an area problem, here's how we're setting it up. 140 over x equals 9 over 16, cross multiply. 2,240 equals 9x. Divide both sides by 9. Your final answer is 248.9 meters. One more example. An 8 by 10 photo is enlarged by tripling the dimensions. How does it affect area? So instead of using the 1 to 3 for the linear relationship, we're going to have to go build the 1 to 9, since 3 squared is 9. Get your original area by doing 8 times 10. Obviously, 8 times 10 is 80. But now we have to be 9 times bigger than that. 8 over x equals 1 over 9. Cross multiply and solve. I hope that helps you with this unit. Go on and work on the assignment now.